We're going to repeat the whole thing now.
Oh my God. Okay. Take two.
Take two. Take two? No, there was a big intro. Everybody on YouTube and
It
at
was
home,
amazing. Everyone laughed. It was fabulous.
yeah, it was good stuff. You missed it all. Megan Dawson, round of applause again. Okay.
Hey. Okay. That's all right. So I'm the modeling automation team lead. So we're sort of a data science area. We use Julia programming to solve a lot of mathsy problems. So I'm going to kind of talk to you about what I've done. So both in education and then in the work, and mainly focusing on the cool things. So I got videos and stuff I can show off as well. And kind of along the way, I'm hoping to sort of talk about the pros and cons of different things I've done. So the winding path through a whole load of different industries. But keep in mind, this is just my experience. So that's what I'm sharing today. Okay, so I'm sort of old. Who here was born after the millennium? Yeah, God, that's very scary. Okay, so I was in high school around then. And then I went and I did my undergraduate. And so here's my first caveat. I didn't do a maths degree. I did a mechatronics engineering degree. I did want to do a maths and IT degree, but my parents said no because they were both in IT. And they're like, nah, you don't want to do that, do engineering. But in my heart, I wanted to do a maths and IT degree. And I have kind of followed that path. So I'm working as a programmer doing maths and algorithms. While I was there, and I was at QUT, so no booze and throwing things, but that's where I went and did my degree. And while I was there, I also did a project over at CSIRO, so a computer vision project. So that's a Starbug, which is an autonomous submarine. I'm going to talk some more about that soon. And also, I then went and did my PhD, and I did that here in the School of IT Electrical Engineering. And I had 2 kids, which is why it took a fair few years. All right, so to elaborate, and I do encourage everyone, if they get the opportunity, to do anything you can outside the uni in the real world. So if you can get out there is some intern things you can do. I know Fugro also offers interns, so if anyone's interested, you can talk to me about that after. So this one I did at CSIRO was a vision-based problem. So they have this Starbug, so that's the little submarine, the yellow one. And they also had this, well, they were planning to build a surface vessel and these little sensors. And what they wanted is for Starbug to be able to see these things and go and pick them up. So it had a little claw on the end. My now husband worked on building the claw bit. He's more into hardware than me. And I did the software to try and find out where these objects were. So the pole itself is just PVC piping, and we use duct tape to create different spacings and sizes of the black and white. It's basically a very simple barcode on it. And I wrote this in MATLAB back in the day, and I learned a lot doing this. So I didn't do a huge amount of programming in my degree and getting the opportunity to do it outside. And you guys get to do a course, which is good. So my approach initially, sort of down the bottom left, so was an image-based approach. So we did some Gaussian filtering. So basically trying to make the image look as clear as possible. The Huff transform is to try and find a line in the image. And then we started breaking down along that line what are those ratios of bandings. But one of the things that I learned is when you try and get this to run, well, back in the day on a quite small CPU, it was way too slow. So in the end, rather than using some fairly nice classical maths, we used a very simple approach. So here you see kind of these the green fans of lines out and the lines on the side. So rather than try and detect and find a line, we just basically did a search. So we looked at those different angles and the different sizes, and that was much, much more efficient. One of the beautiful things about if I'd done it in Julia, of course, it would have been super fast. But back then it wasn't an option. And the Kalman filter, so once, if you have it in an image and you detect the thing, you want to track it over time. So the Kalman filter is a way of doing that. All right, so now my PhD. So this was looking at different ways we use GPS, so how we work out where we are on the world, and the statistical properties of those different estimation methods. So some of the results, so that kind of picture with the green is where we can get the different number of solutions. So if you're out in space, it can be problematic. And here, this one where they all happen to line up with a certain amount of error, your estimate can be really, really bad. So one of the things I kind of learnt while I was doing this, and by the things I've chosen here, is I really liked the simulation side of things. I mean, there was a lot of hard math and there's a little bit of math on there, but I really enjoyed putting it into practice and seeing the useful results that came out of it. So that's kind of where I decided to tail the way I went later on. All right, so now during my time doing that PhD, I did a lot of little part-time gigs as well. So I came out of my PhD and I was like, I probably don't want to do research. I did initially want to go to CSIRO from my undergrad days, but there wasn't as many opportunities. They actually scaled down CSIRO at that time. So I decided to look for real job. And this is kind of all those jobs I've had over time. So first off, the part-time things I did during my PhD. So Shell, oil and gas, one of those big companies. It is interesting to work for a lot of different places. So from the big corporations to the smaller startups, and kind of get a feel for where you like working. I've kind of found out I like sort of in between, in the middle. But it's good to try out those different options. So that was for a forecasting system. So if you have these wells that are producing gas and the curves for what they think that production is going to be, and then you have the rest of the system, so basically the transportation, refinement, and processing, you can kind of, from all those different pieces of information and the limitations in the system, forecast how much they're going to get out the end, and then they can make contracts and sell it. So that was one of the things I built. The other one down there, the pneumatic leaks on a train. So let's say you've got big, long trains. So the big ones that have all the coal on them. So they have very, very long, lots of carriages, and they want to know where the leak is. So they would drive the train past and they would have two different pieces of information. They'd have something listening to hear the leak, the like sound, and then they would also have a little sensor for the wheels. So from the triggers of the wheels, they wanted you to say, well, where on the train is it? Like it's this 11th carriage 3 meters down, for example. So converting that information into something that they can action and use. Oh, let me just kill that off. All right. So now I'm going to also talk about the full-time, or well, QSuper. I was part-time initially because I had my 2 small children. So that one's a kind of finance industry. So that was 3 days a week. And then I worked at Boeing PWI. So you can see the picture of the drone. And then I worked at Fugro, which well, you can see there's origin here, but I currently work at Fugro. So I left Fugro and then I decided to come back. And now I'm going to talk about these all in more detail. All right, so first off, there's the Boeing video. Hopefully people can hear sound online. Hold on. Sound. Oh, there we go. Oh, they can't hear it. Yeah.
Red flag is on. Launching That's really nice.
Oh, sorry. Let's see.
Very exciting times. We're really just at the start of the RPAS journey.
This is my favorite bit. Okay. Hold on. All right. Yeah, that's better. Back to that one. Okay, so they have this drone. They launch it off a catapult. They can send it flying to inspect things, take lots of pictures and imagery, and then they have the big catcher. So it's basically a big line, and there's hooks on the end of it, and they fly it into it, and the wings slides down and the hooks, and it spins around on the wire, which is kind of cool. So the bit I was doing was once they have the image that they've captured of these well sites, they want to answer certain questions. So rather than send someone driving all the way out there to check, they can launch these things, have it collect all the data, be processed, and then they can get their results straight away in a report. So from that image, top down, we wanted to answer certain things. So first, it was important that the fence was completely complete and enclosed around the well. So they're often on farmland and they didn't want cows to get in. That the signs are up on the fence. Now, from a top-down image, looking at a fence, it's pretty hard to see if there's a sign on it, but you can see if it's fallen off and it's flat on the ground. So we're basically trying to make sure there weren't any of them. The kinks on the hose. So they have these big tanks that are collecting water. So that's one of the outputs of the well. And you had to track from that output all the way down through the hose that it wasn't blocked. So if it was kinked, the water couldn't get out, which was bad. And then other things like there's no water on the ground or that certain levers were on the right position. That one was too hard. We didn't manage that one. So that was a really great learning experience for me. And I still love doing computer vision. I think it's kind of a gateway drug into some of these sort of areas. And I learned a lot of things. One of those things is that the data is always your worst enemy. Getting the high quality inputs is really hard. The importance of software, and this was all done in C++, which is certainly a more extreme kind of software than I'd done in the past. So I learned a lot about how some of those kind of hardcore memory optimization things. And then edge cases. So even if you can do this 99% of the time, how are you going to handle the times you get it wrong? And that's the human in the loop question mark. So essentially, we would take a best guess at it, and then the image and a human would go, yeah, that's right, or nah, try again. So that was, really important learnings. Okay, so I'm going to cut, because I went to Fugro and then I went away and came back, but I'm going to do the other one first and then talk about Fugro as a big block. So Origin Energy was another oil and gas place. So there I was looking at their methane emissions. So they have this truck, the picture of it down the bottom, that they drive around that has a lot of sensor data on it. So it has measurements of methane. It also has like your GPS, so where you are. And we had years of data for this truck that they've been driving around. Predominantly, they would drive it around, and if they got high measures, they would know and send someone out to fix it. But they wanted to know if there was anything they could use in that data to do anything predictive. So if, for example, one of the types of wells was much more prone to leaks, could they tell that and make changes about what equipment they used? And this is a really interesting problem. It's big geodata, which is something I've done a lot at Fugro with. And one of the more challenging bits of it is because we had so much of it, years and years of data, we actually had to build something nice to extract and do it in a sensible manner. So we built a lovely little serverless application. We had some spatial indexing on it. And that was kind of a nice thing to build. But the biggest challenge, even though there was 4 years of data, because it was only one truck and they had 2,000 wells thereabouts, you didn't have much long coverage of each well. You'd have a snapshot maybe every year. So it was very hard to make enough correlation and get enough statistical basis for any of those sort of decisions, even though it felt like so much data. It was not enough. All right, so this brings, oh, I'm going quite fast. This brings me to Fugro, which is where I'm currently working. So Fugro deals a lot with geodata. We deal across lots of different markets, so energy, infrastructure, and water. We do a lot of remote autonomous boats, and we're heavily moving towards the sustainable net zero goal. These are all electric vehicles, and we're trying to get rid of all our big vessels and reduce our impact, which is great. What do we do with all these? So we do lots of surveys. So any sort of big project, if you want to know where to put something or how your big something is doing, that's kind of what we do. So we have a lot of sensors all around the world, and it's all just big geodata. So Fugro roams, which is my little bit of Fugro in Brisbane. We are a subset that we don't do any of the boat stuff. We do all the land things. So we use LiDAR data, heaps of LiDAR data. So that's where a plane flies across and scans down the laser. And that pulse, you get a return signal, and from it you can decide what you've hit and how far away it is. I'll flick to my other slides because I think they're a bit better. Oh, do I do the video first? I'll do the video and then we'll go back to the slides. All right. Oh, sound. Hold on. Where's sound? Okay. It's not that exciting, the sound. Playing. So we kind of spun out of a power application initially. So I've got a slide here on LiDAR data. I'm going to have to refresh that. Okay, so here you can see the plane and the point cloud. So each signal that is sent out, and from your return, you can get the XY position of the thing you've hit, and the reflections, which is a measure of how much of the signal has come back. So let's say you've hit something nice and flat and reflective, mirror, you're going to get a very strong response versus a leaf off a tree, for example. We also get potentially multiple returns per signal you send. So let's say that's a leaf of a tree, but some of the signal penetrates and then you get a response from the ground. So you can have multiple, get up to sort of 6 in some cases, probably the most I've seen. And it's really cool data. You get a lot of accuracy, 2 to 3 centimeters. You can capture it quite efficiently so you can also put these little things on drones, but we use light aircraft, and we have crazy amounts of data. So 1.2 terabytes per system per day. Processing that is quite challenging. All right, I'm going to flip back to my other slides. Sorry.
Megan, 1.2 terabytes, how much is that? Let's
Sorry?
1.2 terabytes, putting it in laptops.
It's more than your laptop generally has.
Also as part of the class. So laptop would have a giga,
A good one will have a 1 tera solid
so
state.
kind of a full laptop of data a day, but an expensive laptop.
Yes. High quality laptop. Yes, so we spun out of power. We're currently migrating into lots of different areas, but power, and I've been there a while, has been what I've initially been working on. So first off, once we have this point cloud, you can kind of see in that image, you get some returns on the wires. and some returns on the poles. And the power line company wants to know where all their infrastructure is. So we have an automated process of trying to find that in the point cloud. So find those wires and poles. So I worked on that for a bit. Asset matching. So that one here, I've got an image. So here the triangles or the circles are basically the pole locations, and those red lines are where the wires are between. So we refer to that as a bay, which is a group of wires between two poles. And here you can see the red and green ones don't match up. So let me try and remember which one's which. One of them will be what we found in the real world, and one of them will be where the client thinks their network is. Now, the reason you want to try and match these together is you want to be able to pull across some of the information from the client schematic. So they might have specific information in it, like what voltage those wires are. I can't tell that from the LiDAR. They might also have information like what's on the poles. They might have transformers or a lot more information. So if you can match that across, you can give the client more detailed analysis and reports. And things like if you tell them there's a tree close to the wire, but you can also tell them the voltage, they will send different crews to action it differently. So if it's really high voltage, they have to be more careful. All right, so then this one I worked on is to do with intrusion. So do I have a wire? Okay, still this is my wire. All right, so let's say you've got it's not going to work. Hypothetical wire. All right, you're going to have to use imagination. I've got a wire and you want to know if there's a tree close to it. But let's say you've done this at huge amounts of scale and you have lots of trees that are close. So you might also want to know, for example, well, is it kind of on top? So it's an issue, it's going to fall under. Is it to the side such that if the wire swings, it's going to be a problem? Did I capture it on a cold day and it's coming into summer and it's going to sag down further into the tree? So we have the concept of our banana model, which means the wire can swing from side to side, and it can, by changing temperature, it can expand and contract, and we can perform all sorts of rules on that shape as it is. And it's fairly complicated maths involved in that, but the main challenge of that was doing that at scale super efficiently, because you're paying for everyone you put through your cloud compute. So we want this to be very efficient. Yeah. All right, I'll go back to my other slides again. Sorry. Okay, so that's kind of the stuff I did before I went to Origin and came back. The last couple of years, we've been working on moving from our very bespoke power solution to a more general thing that can be used across many industries. So going back to we get all this LiDAR data, all this point cloud, and what sort of useful information can we derive out of it? So classification is a big one that we can sell as a product in and of itself. So that's for all those points. Can you tell me what they belong to, what we've hit? Is it a building? Is it the ground? Is it there's road in turquoise there? Vegetation is green. So that's the classification per point. Then we want more detailed information built up on that. So that's, say we have all these points and they represent one tree or one car or one building. And then you can continue to build on this representation, this group of points. Can we change that into, say, a model or a mesh? So if you have a look at this building here, you can see that on the side, we don't get a lot of returns. So depending on how you've flown and what angle the laser was at, you might be missing sides of things. So if you can create an entire mesh representation, when you're then doing your further calculations on top of it, you've got a better representation to use. And that's the next level we go to. So analytics. So once we have all these objects, potentially meshes or groups of points, what risk or what information can we answer? So someone, let's say you're the government and you've got some really nice detailed point cloud of road signs, and you want to say, well, if I was driving along my road, is that road sign visible? Or if you have this tree and it's growing up, and it's going to be an issue with a road. So those kind of interactions between the different objects and models, and what questions we can answer. There's also detailed information around the object itself. So you might want to know the volume of your tree. You might want to know the biomass. So let's say I own this piece of forest, I'm growing it. I want to know how much wood, in theory, I could harvest. So detailed description of those objects themselves and how they interact with one another. Okay, so now I'm going to talk about point cloud classification, and I'm going to talk more about how we've kind of built our process. Point cloud classification is the thing we've kind of got the most developed, so I'm going to use it as a test case. So here you can see kind of the Giphy. Our classes are models, and they've kind of built up two things. So first you have your machine learning, so your features and your machine learning, and then you apply kind of your cleanup algorithms, but they're modeling in a sense. So we know that buildings, for example, tend to have nice flat roofs. So if you've got a building point that's just in a tree, some of them are up in the tree, you can eliminate them by using geometric models and information about them. Walls of the building also, there's quite tricky without using a modeling approach. So now this is how we use Julia and do this point classification in scale in the cloud. So we have our 3 deployment branches and different environments. So we might do something in dev or in development first. So let's say you're putting a new model together to find cars. So you do your research, you'll find some papers, a decent approach you want to give a go. You might write some code, hopefully some tests, and then you'll raise a PR, so a pull request to the repo. People will check it, probably red pen, no, you should try this, blah, 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 blah. Once everyone is happy, on merge to our dev environment, it automatically triggers off our training process. So this happens at scale in the cloud. On the data, so the machine learning component of your model will learn, and then you can look at those results. So you might have your confusion matrix, which is a measure of your accuracy in the classification output, and then we can deploy to UAT once we're happy with that. UAT also has some great automated processes we've built up where it runs that model on validation, so unseen data. And then those results are plumbed through to a dashboard. Everyone loves a dashboard. And then from there, we can deploy out to all our production environments and everyone can use it. So here's kind of our cloud infrastructure. So once we've deployed something out to production, how we run these classification models at scale. So we have, so we use AWS infrastructure. And built on top of this, our head node, which is an ECS backed, basically a web page where you can go in and decide what you want to do. And it will then spawn out all the worker nodes and grab the data from the cloud, do all the processing, and then output it back to the cloud. So it's probably a little hard to see here, but this pipeline, so this was running, it took 15 hours to run. It spawned out to 3,093 tiles. So those are different blocks that are run in parallel. And so we scan the data and we know its tile, and we also know about the surrounding information, so you don't have issues with edge effect. You need all the context to be able to do the classification. All right, so this is how we build it. So we build a Docker to deploy. We use Julia 1.10, which is pretty decent. That's the LTS one, I believe, is going to be now. And we pre-compile the system image to make it fast. So I don't know how much Julia you've done, but if you run something the first time, it can be slow. And then it speeds up, so it compiles that code and runs faster. So we run everything in our tests as we're building the Docker to make sure it'll be fast when we're running at scale. Because if you're running in 3,000 tiles, you don't want to be slow the first time. It's a large Docker file too. And this is the GitHub action. So you can see our automated processes to up our versions, to build our Dockers and deploy things. And so this is the model one that also kicks off the training. And this is our training pipeline. So from those GitHub actions that someone's made a model change, it will send a message to our head node, which will then spawn the pipeline to do the training. If there's any questions, please say now. All right, and then this is UAT. So UAT we deploy. So those were the dev pipelines. This is the UAT one. This is the UAT one that triggers off our testing framework. So this, user acceptance and testing. Yep. So this one is mainly for our SMEs, so our subject matter experts. So the idea being that we do all our stuff in dev, we get it working, we're happy. When we go to UAT, it's for the business, inverted commas, to test it and say if they're happy, and when they're happy, we then go to production. So it's kind of a gate to ensure the quality of our models is up to scratch and everyone's happy with them. And this is a screenshot from our dashboard. So this is where we've created tests to show how well our classification is performing. They're not all green. We don't have 100%. That's because these are really hard tests. So we specifically picked cases where it might be a building roof with a tree overhanging and connecting. So these tests, if we were 100%, I'd count that it's done, essentially. So we're constantly trying to improve. Test-driven development. And this is just one of those specific models. So the test cases we can track. So here we've got like our flat points, rolling ground, steep mountain, and we can see how accurate we are in those very specific cases. And one of the other things we look at is how long it takes to run. So the bottom graph is the cost, essentially. So it's the time it has cost us in EC2. And we did have a big push to make it more efficient. So that's why we started compiling the system images, and a few of the ways we tiling we made better, and it's reduced our cost of doing this. So it makes people happy. All right, so those are my slides from that one. Let me just check if I've got any more over here I haven't spoken to. Oh yeah, so this is just a slide of all the different things I've kind of tried out along the way. I've done a lot of languages. Julia is my favorite. I think you're all very lucky to learn Julia. One of the important skills I've kind of picked up as I've gone along is the cloud computing. Yeah, if anyone's interested, I think that's super useful and very, very marketable as well as a skill set to get into. I also I like kind of getting out and talking to people. So I've run the journal club, although running that over COVID was not the best timing, but never mind. And now I'm a team lead, which is certainly a very different set of skills. One I'm still continuously working on, but looking after people is hard. And finally, this is just a little plug. If anyone wants to do an internship over summer, Fugro, and we're putting together the briefs for the projects. We take a couple of students every year. It'd be great to have some of you apply. All right, I brought lots of questions though.
First of all, let's thank Megan. Thanks. Now, I'm sure there are questions. And if not, I can also get some going.
Yeah, so how big of a company is Fugro? Like how many different locations is it?
Yeah,
across?
so Fugro is a global company. So I think it has over 10,000 people. However, in Brisbane, we have 60. So it's a nice little size and we're kind of all working on our little project. So it has the benefits of being a big company with the niceness of being small where we are and we all know each other. I did also get to go to JuliaCon. So I was there a couple of weeks ago. So that's in the Netherlands. So Fugro is the global headquarters are in the Netherlands. So I also managed to, well, I had to go visit the head office and got to go to JuliaCon.
Oh, okay.
Yeah.
Cool. Yeah, that sounds like a good size.
When you guys are doing like predictive modeling, how do you deal with overfitting to the data?
Yep. We do have a lot of data, I would say. We have tried lots of different models. So in terms of deep learning versus the more classical machine learning approaches, you do have to be aware of it. But given the amount of data we have and how carefully we select our training examples, and then even within those examples, how we pick the specific areas that are of interest and that we need to train on, that's quite a robust process. We did also have to set up big links. So the training data we initially got was at the level that we give to clients, which is a good level, but it's not perfect. And you want as perfect as you can get for your training data. So we did, because we have people that manually, human in the loop will correct this, any major mistakes after. So we did have a lot of backwards and forwards with getting the corrected to the level we wanted, which is very high.
I'll interject with a question. So say that I'm a person that's finishing an undergrad or master's or a PhD, young person generally entering your team.
Yes.
What do you want from me? Why would you take me? And how will my day look? So it's kind of two separate questions.
Yeah. I'm gonna go how your day would look first. So we do a normal agile process. So we run 2-week sprints. We have tickets on Jira. Every day in the morning we have a stand-up, which is where everyone gets together and says what they're working on, how it's going. We do weekly whiteboard sessions, literally on a whiteboard, working out stuff. Day to day, there's code testing, meetings. There is even some, Zihao got to do some really hard integrals the other day. I was like, you never get to do that in the real world normally, right? So there is some proper maths as well, and a research approach too. So you do go and read the papers and see how other people have done it. What do I look for when I'm hiring someone? Generally, we don't get people that have done Julia just because it is quite hard to find. So I'm not insistent that someone has a very specific, you see some jobs like you must have 5 years in this programming language. We don't do that. A willingness to learn, a creativeness at approaching problems, and a good communication manner. We do have lots of discussions, and I think having diverse discussions and hammering away at a problem from all different approaches works the best.
Just kind of as a follow on from that one, did you feel like when you went into every new job, you needed to completely relearn skills, or was it kind of I've already got skills?
No. I've also changed languages basically every job. So no, I make it up as I go along most of the time. I think that's normal. I mean, most companies expect that it takes you time to onboard and learn their way of doing things too. So I wouldn't, it is nice in a sense when you start somewhere new and you can kind of decide how much fun you're going to be or how much often you're going to bake or that sort of thing. But people expect you're going to take time to learn skills.
So coming back to Shell, where you're working in forecasting, I've worked with vector autoregressive models, and I would like to ask you if you're doing linear models or non-linear, or if it was already a more machine learning approach.
Okay, no, it wasn't anything that so the curves they have for the well production are already fairly defined, and the blockers in terms of the limitations of their processing facilities and where you could route it through weren't super complicated in the sense that you didn't need anything too much to optimize. So it was essentially aggregating the input and applying the constraints and getting the output. Yeah.
So, with the many jobs that you've had, are you being employed into the problem that you're being asked to solve, or into the company and then they kind of present something to you?
Yeah, I think in general, I've been hired to do a job and they've come up with lots of different problems. There's always more work. I've never had the issue where I finished a problem like, nah, sorry, we're done. So I think, yeah, in general, maybe some of the initial stuff I did, so the part-time work, like the road train, that sort of stuff, was this is the problem space you're solving, and those were more contract positions versus the permanent ongoing ones where there's just constant work coming up. You do always have space to refine what you've done. So at Fugro, I've done lots of different stuff now. And sometimes I wake up at night, oh, actually, I should have done that. So you do sometimes get the chance to revisit and make things a little bit better. So that's nice. And a lot of the work I've done at Fugro has been patented, which was a whole new experience. I don't like lawyers. Oh, this is recorded. Whoops.
What would you say is the most valuable skill or experience you've had over your career?
It's hard to say one thing. I think having a variety of different experiences has been good. I certainly think I am getting, well, slowly, hopefully getting better at stuff. For example, I've historically been terrible at public speaking, but that's something I've been working on over the years and getting better at. So I think, yeah, maybe a willingness to continuously improve.
Have you always worked in Brisbane, or did you do?
Yeah, I have always worked in Brisbane because I had kids, well, early on when I did my PhD. We've kind of been tied to Brisbane. I've not wanted to move around too much. I do think if you're doing academia straight, for example, it's beneficial if you can move around. There's probably Brisbane-wise constraints in terms of how many places do Julia. Now I really like Julia and won't want to part from it. So that would kind of put limitations, I guess, in staying in Brisbane. But I haven't really found it that constraining, really. I like Brisbane.
Why is Julia your favorite programming language? And is it like related to the fact that it's like well tailored for the specific work that you do, or is it just, do you just like it?
Yeah, I think it's a beautiful language in and of itself, but it is also super fast, and it does have the most of the benefits of Python or MATLAB in that it's quite easy and high level to write. One of the downsides versus those languages is just because it's not as widely used, it can be harder to find the packages or support, and you might have to build a lot in-house. So we have over 100 repos in Fugro that are our own little private base, and we've had to build those up just because it hasn't been available out in the more general space. But you do also have more control because of that. And because it is young, you can kind of tailor and ask for help in other packages. The pros and cons. Awesome.
Many jobs that involve mathematical modeling or statistical modeling tend to also require a PhD. Do you think there is also space for people without a PhD to work with mathematical statistical modeling? And maybe do you have any advice?
Yeah, very much so. So, okay, Ben, he's the one over here on that image. So he did a maths degree at UQ. He came and did our summer intern project, and he's been working with us full time, 3 years now. And he's really great. And I've told him not to do a PhD, one, because I need him at my team, and two, because you don't need a PhD. So yeah, I certainly don't think you need one. If you're heavily motivated and interested and want to do one, by all means. But if you are interested in industry applications, I wouldn't recommend one. Wouldn't. You want a rebuttal?
Actually,
Yeah, go on.
Well, no, I do want to ask you something. So this is a theory I have.
Yeah.
And the theory is, so we're looking at Ben here. Poor Ben. Hi, Ben.
Yeah.
You made a case out of you if you ever watch the YouTube. So a talented undergrad, they finish here, they finish their bachelor, they get a job.
Yes.
They still like to kind of do stuff that's completely kind of free.
Yes.
Because at Fugro, at the end of the day, you have to deliver by the end of the day, right?
There is some limitations to problems. You need to work on something that's vaguely useful and that we can make marketable. Yes.
Fair enough. I mean, it's a business.
Yeah.
So they get the job and then they start to earn 50, 60, 70, 80 and get a partner or some lifestyle, etc. And commitments kind of rise.
Yeah.
And then that desire to actually go back and do a PhD at kind of a much lower
Yeah.
income.
That is
what's
a
about
hard
this?
thing to do. So Ben in the past did want to do a PhD and he's come to the decision it's just cost-wise not worth it. You do have to have that trade-off essentially. So if it's something you really want to do, you'll have to pay that price. But I would argue that the work we do is, if not more interesting, and the satisfaction you get from solving these problems, I personally found it more rewarding than my PhD.
No, with that I fully, yeah. So the rebuttal is almost done, yeah. And
Yeah.
and me myself, I've kind of 50% out of academia trying to deliver. And it's kind of interesting that just the Julia thing. So through Fugro, Claire, that will be teaching here, really drove that in Fugro, and Paul Bellet, whom the class will meet next week,
Yeah.
that actually influenced me. So I work also in Julia in a company called Pumas, so from Brisbane, but they're in the US mostly. And then Andy Ferris, who
Yeah,
this
he's
guy,
on.
so you'll see him on the recording. So his company as well does Julia. So of course it's a niche thing, and but actually at UQ, by actually having this course, and it's kind of related to Fugro, when this cohort and the ones before you go to industry, sometimes there's a bit more.
I refer to the group as the Rome's alumni, basically. So we've all been through Rome's and we've all been indoctrinated with the Julia way, and we're slowly spreading it out into other companies. So one day it'll all be flourishing everywhere.
Maybe it's
a nice thought.
There's probably another question or two. There were some great questions here. One more. Yes.
Do you ever find, like, because you had experience in C++, that with Julia, if you're trying to optimize stuff, do you ever find you need to do things a bit more of a roundabout way to get it to have the right performance? Or
we do have a team in Brisbane that also uses C++, and it has been somewhat competitive between both teams. And we've found that with Julia, we can get as fast. Sometimes you may need to, say, type your function or vectorize or do a few little tricks, but you can, or at least we've not found a case where you can't, get as fast as C++.
yeah, cool. Thanks.
Thanks. And any final? Yes.
How constrained have you found your work to just the maths? Like working in companies with like a variety of applications, how often do you have to consider the real world and the impact it has on other people, and how much is it just sit at your desk, stick to the maths, do the code? How much interweaving is there between the two?
Yeah, so all the different little places and work I've done has been that intersection between wanting to solve a problem and it's not got a clearly defined solution. So you kind of find your way between the research and different approaches. Sometimes you come up with something yourself. So the interaction between the strict maths research side of things and getting something that works is a little bit of a trade-off. And you do have to sometimes relax, in a sense, some of the strict maths, and your perfect accuracy. You don't necessarily need 7 decimal places in your position, etc. So there is that tension between it being good enough and getting the solution out, and sometimes me wanting to go the nth degree of perfection. But yeah, you have time constraints as well around it all.
Yeah, I think I was more trying to get at, like, with working at companies that were producing like drones and in oil,
Yep.
were there any like ethical considerations you had to come across? Or would you stick
Yes.
to just your maths and
So
be happy with that?
I've always been lucky in a sense that I feel that my work in those areas has reduced the impact on the environment. I do know, so Ben's one of those that would never work in oil and gas and as morally and ethically opposed to the industry. I have worked there, but I feel that there are places where you can make an impact and a difference. So I know, saved stuff that would have been vented to the atmosphere, for example. So you can, helps you sleep at night when you know that you have made that positive impact.
So, I really enjoyed hearing this class questions. I'll ask the final one, and that's just what makes your day? What's the best kind of, what are highlights? What are gems?
Lots of highlights. So I like it when I can get in and solve a problem, when I make a really nice piece of code that does the business. That makes me happy. I do really love mentoring people and seeing other people do that too and bring them on board, which is great. And I also really love socializing and having fun with my team. I think we're a great bunch of people, and we do stuff together as a crowd, and that's amazing too. Those be my three.
Thanks. It makes me want to work in your team.
Ah.
So let's thank Megan, and thanks a lot. Wonderful talk, and I hope I can safely say don't be a stranger. Connect to Megan on LinkedIn or another means, and yeah, thanks everybody for coming. Okay. And thanks for the people at home.
Thanks. All right, what do I do to the Zoom? Oh, something. Good, I'm getting better at it, I think.